what it is, painful questions that have 14 parts each. I know, I'm sorry. I'm so sorry. I really am, honestly.
If you're sorry, you take at least 2 of them off.
No, because that's why I'm showing you this on video. So,
That's only part of the homework. That's not all.
yeah, but if you get one wrong,
Hold on, I'm doing something really
all
different.
over again. All right. So, look, this is why you don't wait till the last minute to do the homework, because you never know when there's going to be a 14-part question. Yes. Yeah. This is not due till Sunday night, so you should, one question per day, and then along with the other questions on the assignment. I mean, no big deal. You got this. How many total questions? So look over here. Here's the difference. Here's why there's 4 of them. What type of function is this? Linear. What type of function is this? You got 2 linear functions here. This should be the easiest one, this one, because they're just linear. Meaning the domain and range here is all real numbers, the domain and range here is all real numbers. Now if you start putting them together, you just have to watch out for these 2. Because when you create a fraction is when you run into the rule in math where you can't have what in the bottom? You can't have a 0 in the bottom. So here you'll have to pay attention to what would make function g 0 in the bottom. What would make function f 0 in the bottom. So looking at it real quick, that'd be -7 divided by -2. So x cannot be 7 over 2 for function g. So when g is in the bottom, like right here, you would say it's all real numbers up to 7 over 2 and skip over that. That's right here. So in terms of the visual, yeah, I just said it equal to 0. That's all. I subtracted 7 divided by the -2. Negative over negative, positive, yeah. And they don't want decimals. They want fractions. So this problem is linear. You might want to take these notes. This problem, 6, is linear and square root. Remember, we wrote it at the very beginning of these notes. We said, recall, the domain for fractions, denominator cannot be 0. Domain for even roots, you can't have a negative under an even root. So like this one right here, whenever g is in play, here and here, you would have to say x has to stay greater than or equal to -3. That's from chapter R. You remember this from chapter R. You take the radicand and you set it greater than or equal to 0 and you solve, and that's your restriction for that even root. So anytime g's in there, that's going to be your restriction, because you cannot plug numbers less than -3 in there or you'd have a negative root, and that's not possible. And then here, you're going to have to be careful, because not only is g in there, now it's in the bottom of a fraction. So -3 is no longer allowed, because if I plug -3 in this, I get what? I get 0. Square root of 0 is 0, and in this, it would be in the bottom of a fraction, which would be an error. So to modify it here, you would say x has to stay greater than -3. You take that or equal to off.
So for a side note, he wants to just say make sure that the denominator is
So we're fixing to do this like in your notes. If you're wondering, wait a minute, we haven't covered this. Yeah, we haven't done it in your notes yet. But I would say like number 6, radicand greater than or equal to 0. And then I'd make a note, when it's the fraction, it would just be greater than 0. If the radicand is in the bottom of the fraction. Now, does this one matter? Like in the bottom of the fraction? This one? No, because that has F in the bottom. So you do still, actually I say that, let me erase, because you can't tell what I'm pointing to. So if this is in the bottom, let me just find it. So first I'm going to write it. That would be G over F. So that's the function. What's the domain? Well, the first problem right here is, change colors. This has to stay greater than or equal to -3. This cannot be 9. You see that? It's the same rules every time. Even root, fraction. It's always the same. The numbers change, the problems change. But is it a fraction? Bottom can't be 0. Is it an even root? Can't be negative. It's the same every time. So to put this together, you need a visual. You got -3, you got 9. This is saying can't be 9, so that means open. This is saying greater than or equal to -3. So it would be negative, watch out. It'd be -3 to 9, skip 9 to infinity. That's what that one would look like. You're having to put them both together. It helps to draw the number line because then you read it like a book from left to right. And this is starting here, skip over that, and it's going to infinity. So that's number 6. That's going to be the toughest part right there, like the domain of those. Can I erase? Good. All right. If not, it's in the video, and the video actually does have sound now. Look at 7. What's that? Cubic, quadratic. This one should be another easy one. This one's like a linear. You just have to be careful when you get here, because you're putting one of them in the bottom. So let's do this one first. When F is in the bottom, because that is just x cubed, the domain there would just be, okay, you can't have 0. It's got to skip over 0. Any number is allowed, but it's got to skip over 0. So it would be -infinity to 0, skip 0 to infinity. But now when you switch them, literally switching them, you have more to do now. You have to take this and factor it to see what makes it 0. So that'd be -42, numbers that add up, factors of -42 that add up to 11, and then you would do that whole AX number, and reduce whichever one, and set those equal to 0. That's from chapter R. Yes, we'll do that when we get there. But that's going to come into play. Number 7, when the quadratic is in the bottom. Okay. And then the next one, is there another one?
Yeah, number 8.
It's 8. Ooh. Fraction and fraction. So, I think when you're adding and subtracting, let me do this. I think they just want you to write it in there. Yeah. Look, they don't want common denominators and you to clean it up. They're just literally, you're just typing the fraction plus the other fraction. Type the fraction minus the other fraction. Now that, when you're multiplying them, you're just shoving them together. They're not looking for you to clean it up or anything. Same thing there. When you're multiplying f times f, so that would be 8 over this times 8 over this. You can write it like that. They don't want you to multiply the polynomial out. Okay, when you're dividing them, they are expecting you to do keep, change, flip. Okay, so let me work one. We got f over g. Remember what I said before, when you're putting a fraction within a fraction, make the original fraction bar small and the big fraction bar where you're separating them, make it really big so you don't forget what's actually keeping, changing, and flipping. So f goes on top, so that's 8 over x plus 2, big fraction bar, over g. And now I can clearly see what I'm keeping, changing, and flipping. All right, that looks, sorry. That looks really bad. 8 over x plus 2, change, flip, and then multiply straight across. Look, they don't even expect you to actually multiply. They just want you to write it like this is a quantity. This is a quantity. So that would be 8 times 6 minus x over x plus 2, because that was a 1. See that? As far as domain and range goes with those, I'm not trying to rhyme here, but you can see, because we have, look at every single one of these domain and ranges. Every single one of them is negative infinity to infinity, but it's skipping over those numbers that would make the bottom 0. You see that? And that's because from the very beginning, it's a fraction and then a fraction. It is a lot. Welcome to college. I know that. It is a lot. That's fine. That's why I wanted to record it for you. So the first 14 minutes of this video is me going over all those problems. So as you come to them, if you need it, use the video. The audio should work now. If you get stuck, message me, reach out to me. Okay, you wrote stuff down from this slide yesterday. All right, everybody join me. Y'all wake up, AirPods out, off your phones. You wrote this stuff down yesterday, so now let's look at it and let's talk about it. It's saying to you that if you have a function f, and you have a function g, and you do anything with them, add, subtract, multiply, divide, take one and multiply by itself. If you do anything with them, then the domain changes. Remember, domain means what's allowed to be plugged in and would give you an answer. In terms of the t-chart, the t-table, domain is the entire list of x numbers covered by the graph. Range is the entire list of y numbers covered by the graph. What we wrote here was we were looking at function f. Where is it? F is linear. Is this? Nope. This is function f. It is linear. This is function g. This is an even root. Linear functions have no restrictions. Even roots do. You cannot take the even root of a negative number. So the radicand, we wrote it right here. The radicand cannot be negative, so it has to stay greater than or equal to 0. And that's how you find the restriction for the even root. We practiced this already. It has not changed. If you take the two functions, the linear and the even root, and you divide them in a way that puts the even root in the bottom of the fraction, right? Bottom of the fraction. Now you have two rules to watch out for. You still have the even root, which means you can't be a negative number, but you also have, hey, it also cannot be 0 this time because now it's in the bottom of the fraction. So you adjust your restriction by taking off the or equal to sign. And the way to know that is if you plugged -3 in here, you would get the square root of 0, which is 0, which is the bottom of the fraction, which is a no-go. Okay? I know domain and range is everybody's least favorite. I know some of you are still struggling with it. I have something that I'm hoping will help here in a few minutes. I'm going to give it to you. But I need you to understand it's the same thing every time. So if you're not good with the math, then get good with the pattern. Okay? The pattern is if it's a fraction, bottom can't be 0. If it's an even root, set the radicand greater than or equal to 0. Unless the even root's in the bottom of a fraction. Then you have to take the or equal to off. Those are the three things every time. That's it. Those are the three things.
I'm just confused because on the first one, on the left, it says that it can equal a negative number, but it has the radicand just can't be negative, and so the x has to.
Meaning.
Because there's -3 in that term.
Meaning, so look at what happened. It's saying that it can't, look at me, sorry. It's saying that it can't result in a negative, but it's x plus 3. So I can plug -3 in, because -3 plus 3 is 0. And it's saying to stay greater than, so I can plug -2 in. I cannot plug -4 in. If I plug -4, I end up with -1. I've just broken the rule of even roots in math. So don't let the restriction confuse you with it can't be negative. The restriction could involve a negative number. What cannot be negative is if you plug it in and you get negative. There's a difference. All right, y'all already wrote that. So now let's look at this. This is not on your notes.
Correct.
This is in the homework. So this would be something to put in your notes and highlight or circle and say, question 9. See video at 19 minutes. Or question 9 and then take notes as we talk about it. So, it's also on the quiz, by the way. I pulled it from the quiz to show you it's in 2 places. So it's on 9 in the homework, and then when we get to the quiz, it's on the quiz as well. They give you this graph, and they say, tell me the domain of the function f, tell me the domain of the function g. Now what if you added them together, what would the domain be? So the difference here in this one is those are piecewise functions. That's not just a standard linear, quadratic, cubic, radical. That is a line, a line, a line, a line, 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 all pieced together, right? Those are piecewise functions. They're wanting to know, can you read the graph and state the domain of just f, which is blue, of just g, which is green? What if I added them together? Don't you dare try to visualize adding those lines together. You would just need to know that in your head that, okay, if I have function f and I have function g and I add them together, I would only be allowed to use numbers that are allowed in both of those, right? So this comes down to your graph. You got to know how to read your graph. F, we changed the highlighter. F starts at 3. Can you tell that? Do I need to make this bigger? Can you see it back there? F starts at 3 and F runs to 14. So the domain of F would be bracket 3 to 14 bracket. G starts 2 to, what is it, 11. See that? So it'd be bracket 2 to bracket 11. All right, what if I add them? You're not actually adding anything in your head. What it means is now I need you to take the restriction on F, take the restriction on G, and tell me what they have in common. So F plus G, let me change to blue, would be whatever number is allowed in both, all the way up to whatever number is allowed in both. So F plus G would be 3 is allowed in both of them, all the way up to 11 is allowed in both of them. So 3 to 11. So you'll notice it ends up, it's the intersection of both of them. Notice like 13 is allowed in purple. Well, if it's not allowed in green, it can't be in the addition of them. 2 is allowed in green, but it's not allowed in purple, so it can't be in the addition of them. Okay? So, question 9 on the homework, you're going to read the graph and you're going to look at what number is allowed in both, all the way up to what number is allowed in both. And that question is going to come up again on when we take that quiz. All right, so this slide you do have. This is where we're practicing. So this is like the homework. We have 2 of these to practice on here. And neither one of, they're both linear and quadratic. Wait, mine matches. Oh, I remember now. What is yours look like? Okay, so there's a lot of writing here, so don't write big, because this is that whole, technically the 14 parts, but in this case we're only doing A through F. You see that? We do have a quadratic, and then we have linear. This is exactly what I just went over with you, the 14 parts. The only time it starts to get really technical is if it's a root or a fraction, which I would argue neither of these are, so that's a little unsettling. But I already went over those with you. Why don't we do this? Why don't we make this one a root? What if we adjust this? And now you'll get practice with it if it's a root. Let's do that. Let's make the function g an even root, and now let's practice. So the first part of it says, tell me the domain of all of these algebraic expressions with these functions. Well, it would help first to know your domain of just them individually. So the domain of f, because it's a quadratic, is there anything in quadratics we have to watch out for? Not at all. Any number is allowed to be plugged in, right? The domain of an even root has a restriction, and that is that the radicand has to stay greater than or equal to 0. So x plus 2 is greater than or equal to 0, and then you would solve that. So slide the 2 by subtraction. So x has to stay greater than or equal to negative 2. Does that make sense? So if I'm just adding or subtracting or multiplying, you with me? You add, subtract, or multiply, then your domain, if it involves G, is going to be this. Every time. Because G's in the problem, we have a restriction, we got to watch out for it. The only one that you have to stop and actually think of is if you are dividing. And that's where the one that's in the bottom is what matters the most. Alright, so now let's look at it. So those are the individual domains. It says state the domain when you add, subtract, multiply, divide. Well, if I'm just adding them, then my only domain restriction is the one that has the problem to begin with. So the domain of adding would be that it has to start at -2 and go to infinity. Greater than or equal to -2, right? That's the interval notation. If I'm subtracting, it's still -2 to infinity. If I'm multiplying, then this crap would just shove in front of the radical. It'd still be -2 to infinity.
Wait, so subtracting does the same thing as
And if this is bothering you because it's redundant, you could write it one time and just, underline those and say they all have the same domain. Now, notice I didn't say anything about the dividing. That's one where you have to stop and think. Let's write F over G. It would be the squared over this, right? We practiced this, we talked about it just a second ago. What would need to change?
It has to be greater than.
You take away that or equal to. So this was my original for the even root, but now the even root's in the bottom of the fraction, which means I actually cannot use -2. So the domain here would just be that, I started to draw a bracket. The domain here would be a parentheses -2 to infinity. Because if you plug -2 in the bottom, you'd have the square root of 0, and that's a problem. No, because of the radical. If the radical was not there, it would be a whole. But because of that radical, it's not a standard rational expression. It's a rational expression with an even root. The root changes it. Now let's find the algebraic of these functions. So B says atom. B. That was good. It's like if you are from Georgia and you pronounce the capital, or no, what is it? You know you're not from Georgia when you pronounce the capital Atlanta. Yeah, Atlanta. What's
Yeah.
Atlanta? The T's silent. Oh yeah, absolutely. F plus G. So I'm going to write function F. That's x squared minus 4 plus function G. We said is the square root of x plus 2. And you would leave it alone. You can't do anything. Now the subtraction, the difference, would be the exact same thing, but that would be a minus sign. It says to take F and subtract G, so that would be this. And once again, can't do anything.
What if it was G divided by F?
Then you'd have x greater than or equal to -2. X cannot be positive or -2, so you would have to adjust this.
I'm stuck.
Alright, F times G. So this is part B. We've got F times G. That would be the quantity x squared minus 4 times the quantity square root x plus 2, and you already saw in the completed MyMathLab problem, like that's as far as they want you to go. They don't want you to actually multiply it out. If it was, what's E? I'm going to do E over here so I have more room. E is F divided by G. G is, or F, part F says multiply G times G. Well, G is the root of x plus 2, and you saw in MyMathLab how they would like you to just write it, and then since it's the same thing times itself, you can write it as squared. Now, in this particular example, though, they do cancel out. I don't think that actually is going to happen. It would just be x plus 2, not the square root. Because they cancel. See, this is squared, this is square root, so the actual answer to that one would just be x plus 2. Because they cancel.
Maybe I was just visually thinking like the square root of x plus 2 times the square root of x plus 2. The square roots cancel, so you're left with x plus 2 and x plus 2.
Oh, no.
Can't think like that.
No.
Okay.
If you had them written out in expanded form, then the x plus 2 and x plus 2 would be squared. And you still cancel, yeah, square and square root. Now, f divided by g would look like this. And this is where we already found the domain up here where we said, you know, you still have the restriction on g, but now because it's in the bottom of the fraction, you would change that bracket to a parentheses because -2 would not be allowed to be plugged in. Yes. And there's no surprises because we went over the homework. So when you get to the ones that are, what was it, a fraction and a fraction, that's where you're just saying, you know, the denominator cannot be what number. I showed you how to do that at the beginning of this video. All right, we have 3 slides, three or 4 slides left. Somehow, I don't know, I have 11 according to my, but. This was
for like 2 minutes. We're all about to fall asleep. Potty break, please.
College classes is the amount of time that you're having to be attentive to the lecture or the lesson. So that is the difference. So yes, we do have more. Let's go. This one we've already talked about. This is just where I had it placed, I guess, as a, I don't know what I was thinking. Let me think it out. All right. So this is where you should be, right here. This is a preview of Calc 1. Calc 1. Difference quotient. It has to do with limits. If you recall limits, maybe in pre-cal. I don't know. Did y'all do limits at all in pre-cal?
I don't know, I haven't done it yet.
So limits don't come up in our pre-cal. We go in a different direction, and we go faster and more challenging with a couple of other, with the trig identities. But limits are part of Calc 1, and it all starts with the difference quotient. We are not actually getting into limits right now. This is just a matter of, can I give you a function, a formula, and you plug stuff in and clean it up correctly. That's the purpose of this, which is, by the way, what you end up doing as you start evaluating limits. If you notice, this right here is called the difference quotient. You will see that it is copied over to the next slide, or the next slide. It's copied over to it, so you don't have to look back. It says for the function f of x equals 2x minus 3, find and simplify the difference quotient. I love these because it is literally plug it in, clean it up. That's all it is. So it's really Algebra 2 skills. What people get confused on is the fact that there is an h in it. It throws people off. It is just a variable, okay? Where?
The denominator first.
Oh, it got cut off. It's an H. Yeah, let me fix that.
I wish there was an infinity key on my keyboard.
Where's it? Oh,
That was worse.
there you go. It is an H on the bottom. If you'll fix that. Okay. So it says take function f, find and simplify the difference quotient. You will notice there are two parts to the difference quotient. If I need to, I'll highlight it so you can compartmentalize. You have this part right here, and then you have this part right here. It means, no, because you're going to subtract. What it means is you're going to plug in x plus h, the expression x plus h, into the function for f. Then you're going to subtract the function f, and it's going to all be over the letter h. All right, so here's what it looks like. Come over here, and let's write it. Y'all know me, I like to be thorough, so I like to write what I'm working with right here, and then I can see to myself, okay, that's my formula. I'm going to find f of x plus h first, because it comes first. That means this right here, this is the function f. It's 2x minus 3. Everywhere there's an x, I'm going to write what? X plus h. So watch how I get this. 2 beep, minus 3. And what goes in the beep? What did we just say? X plus h. That's the first part. Now, I'm not going to clean it up yet. I'm just going to leave it alone. Copy the formula. Minus function f. This is a formula. If you will treat it like that, you'll know exactly what to do. Minus function f. What is the equation for function f? 2x minus 3. Now, that's a quantity, so you need to put it in parentheses. If it's more than one term, you need to put it in parentheses. Or it might not be bad to put it in parentheses every time. And that is all over what? H. Good news and bad news. Good news is, that's it. Bad news is, you have to clean it up. But that's it. We've plugged it in. Now we just have to clean it up. So do you see how I plugged it in? This was x plus h. So everywhere there is an x in the function, I put x plus h. This is just the function f. I literally copied it verbatim right there. It's just in parentheses. Now let's clean it up. I personally don't like cleaning it up all over the h. I like to do what's called an aside, where I come over here and I just work with that top crap because I know the bottom is h, right? So I'm just going to come over here and start working with it. I'm going to distribute the 2, copy minus 3, and I'm going to distribute the negative. See what I did there? I distributed this 2, copied minus 3, and then I distributed the negative. 2x minus 2x. Those Cancel. -3 plus 3. Cancel. What's left? 2h. So I'm going to come back to this, and I'm going to say, okay, all that crap ended up being 2h, and it's over still what? H. What happens? Those cancel, and you're left with 2. Might want to make note right here. Be careful. This was where if you forget your parentheses, that distributing the negative would not happen and you would end up having a mistake. So be careful there. All right, that one was too easy. Go to the next one.
We have this formula on the test.
Yeah. You have to memorize how to do it, like what to do with it. Yeah. This next one ends up being, I like it. It's a really nice challenge, but I have a post-it note to myself, skip if no time. So I changed it. So what I'd like you to do is mark out the f of x that's here, and instead, above it or below it, let's change it to 6 minus x squared, and let's do that one.
What's with the no standard?
Yeah, a lot of it
All
was
of
like
them
6
have
times
like every.
Well, I think that goes under one of those things where I said, Can you work with ugly numbers? Inconvenient, yeah. Are you going to quit just because it's ugly? That was rhetorical. Let's keep that answer to yourselves and use it as motivation, right? Sure. Check the box, y'all. Yes, Miss Holcombe. Okay, that's it. All right. For the function f given by, here we go, 6 minus x squared. Find and simplify the difference quotient, which means if the function f is 6 minus x squared, find this. This is the formula. This means everywhere there is an x, you're going to plug in x plus h. And then you're going to subtract, and then you're going to write the formula for f, but in parentheses. And then you're going to clean it up. So if you want, here's an alternative method. You could say, okay, first let me find f of x plus h. You could do that separately. If it bothered you doing it in the problem, then just find it first. It's kind of like when we were doing solving by the quadratic formula, and I said solve this crap first, right? And then go plug it in. Maybe this will help. Okay, so I'm going to copy the formula for f, which is 6 minus x squared, and I'm going to beep out the x. Beep. And in the beep, I'm going to put what? X plus h. And then now I'm going to clean it up. You do have to clean this up. You cannot just leave it like that. So we do have a binomial of just variables being squared here. So this is x plus h times x plus h. So you got your first, outer, inner, last, or if you know the shortcut for multiplying a binomial by itself, it's that the first term squares, 2 terms multiply together and get doubled, and the last term squares. But if you don't know that, then you would sit here and say, okay, minus parentheses, first, outer, inner, I'm going to write it as the same order, last.
Wait, I don't know if this is what you just explained, but why would it be in that page?
minus. Order of operations.
I wrote my thoughts.
You can't distribute that negative until your exponent has been evaluated. Yeah. That's why you're going to, at the very end, distribute the negative to whatever you get. So now, cleaning this up, notice that these two right here become this, right? You got two of them? Don't get lost in the variables. Those are just expressions. You have two of them. You have XH and XH.
Why? It's the first part that's getting like the f x plus h equals 6 minus x squared,
Oh, this was me copying the formula for F.
right?
This is me beeping out the X and plugging in X plus H right here. I replaced X with X plus H.
So you don't have to put an equal sign at the, like, the way you wrote it up there is just kind of at the very top. Like, it's kind of confusing me. The way you put like f and then you put, because I'm thinking to myself, instead to put x wherever it is in the equation. So I guess I'm just,
It's X plus H
right.
wherever there is an X.
So you wouldn't have to bring down that f with the x plus h in it.
Oh, you know me. I go to the end and I do that.
Oh, okay, yeah, that's what
This
I was
is me working. This is my formula. This is
Yeah.
me working with it, and then once I'm done, I'll be like, okay, so what is f of x plus h? It's going to be this crap.
Yeah, that's what I was.
Yeah. All right. Now I'm going to distribute that negative, and you'll notice there are no like terms, which is why it's probably not a bad idea when you get to one like this, doing that on its own out of the fraction, because there were so many steps involved. But just know enough to know that we are not even done. Like, we haven't even started we haven't done the actual problem. We did that first part over here, so we weren't writing within a fraction, all of that crap. So now, the second part would be put it together.
Could you not put it in standard form?
I don't want to.
Okay.
I don't want to. Because you got two variables in there. So there's really no standard form when you got multiple variables other than exponents towards the front. But you don't need to, because when we plug it in here, stuff's going to cancel. So no need to clean up when you're fixing to have a birthday party in the house,
That's
right? You wouldn't brush your teeth before you eat Oreos. All right. Sorry, I'm full of like weird analogies. All right. That is the formula, right? That's the formula they told me to find. Now, I don't have room to say equals and then work on it. Someone come over here and say, okay, equals. Here's me working on it. I've already found the first part. I'm going to plug this in, and I'm going to write small. That's the first part. Minus parentheses function f. See it? They will. And this is all over h. Now, if it were me, I'd probably go in and erase my parentheses and account for that negative on paper, but I don't want to confuse you by doing that. So I'm going to draw a whole other line and just evaluate that negative in the front and keep it all over h.
That's one.
Then I'm going to go in and clean up 6 minus 6, negative x squared, plus x squared. Every time you should be left with only the terms that have h's. it's leading you into limits. Well, not necessarily all the time. You have let me rephrase that and say you should have the terms that have H's so they can clean up. Sometimes there might be a constant or an X term in there. Let's rewrite this before we try to clean it up. I just brought down what was left. How many terms are on top?
2.
There's 2. Terms are separated by plus and minus signs. There's 2 terms on top. The bottom term is an H. Every term on top has to have an H for the H to cancel. So this H will come out of that term and one of those. So I would be left with negative 2x minus H.
2 H's.
That's 2x.
2xh. Oh, no. And that would be the answer. Do you have another slide?
Yeah.
It's the same problem.
Oh. This one looks.
Anything that is connected by multiplication can be broken up by that division of H. Say again. Multiplication and division you can. Addition and subtraction you cannot. Looking at this is the same thing but with a quadratic. I would love to see if you can get there. Your final answer should be this. That should be the final answer. I would love to see if you can get there. Now, hold on a second before you pack up. Let me hit, for some reason I have 5 more slides. I just want to look and see what it is. I have a feeling it's the 14-part questions. 14 parts. That's linear. Remember we said that should be the easiest one. I'm going to leave this in the video so you can see the formatting of how they want the answers. All of them are here. This one is linear even root. You can see that the formatting of the domain is restricted. This is a cubic and a quadratic. This should be easy because there's no restrictions there until you hit those fractions.
Yeah, I need
And that's a dead slide. Alright, so it was actually 14 slides. So this is in the end of the video. I'd scroll to like 50 minutes if you just want to see a preview of how the answers are written.